Hey, everybody. I'm Omar, the CEO and co-founder of Weavechain, here with Johnny or Ioan Moldovan, my CTO and co-founder over in Romania. And this is the first episode of what we are hoping will be a fun webinar series we're calling The Future of Data. And, to mark the occasion, we even went and used Adobe Firefly to create a fancy futuristic illustration that we think just got those future data vibes over here. So, what we want to do is each week just sort of talk about an interesting topic related to data, whether that's data security, data privacy, data economies, and really sort of listen to what the community finds is interesting. Now, our goal here is to sort of educate you based off of our vast experience, and we'll be reaching out on social media to go and figure out what you all want to talk about. But for today, we thought Johnny and I would just sit around and brainstorm what are the most interesting concepts from sort of a fundamental level and put together a little table of contents of topics that we can go into in future sessions. So, Johnny, maybe what do you think? Should we start with our architecture deck and run through it, or our white paper? But what do you think are some of the most interesting topics in data security that we deal with here at Weavechain?
Let's start with data mission, the mission that we have in.
The mission for, let's say for Web3 data, right?
Yeah. First, we should also clarify what we mean by Web3 data, and then jump into.
Well,
this is Web3. It's such a polluted term that explained.
Yep. Well, this is not a pump and dump scheme for sure. This is, I think, very real security technology. But let's back up a bit. You asked about, what's sort of our mission for establishing Web3 data throughout the world. And I'm very excited about this. Our white paper is still in its infant stages over here, but we talk a little bit about our mission, and we want to go and facilitate the evolution of how data flows between parties. And, the analogy I like to use is, we saw a big shift in data rights when people migrated to using HTTPS connections for websites to show that, I actually know that this is docs.weavechain.com or docs.google.com and that nobody's hacking our communications. And we think that the same kind of shift is happening right now with Web3 technology. And we break it down into, really security features or economics features over here. But let's say whenever data is being transferred between parties, let's say between, myself and a service like Facebook, and then from a service like Facebook to an advertiser, we want to go and make sure that data can't be faked or tampered with first and foremost. So, this is very, very important in a world where AI can go and generate incredible images like, this real quickly, or, the Pope wearing a puffer jacket. You want to be sure that what you're seeing was generated by the source that you intended. And, taking concepts like signed credentials and applying them to data that's outside of websites, we think can go and do that. And then, the reason I gave that Facebook example is that I want to go and know who is using my data and how at all times. So Facebook got into a lot of trouble a few years back after the Cambridge Analytica scandal ahead of the 2016 elections, where, let's say, user data was being shared in a way that was not consistent with user expectations. And the problem is, when Facebook shares data, you don't have any track record of how it's used. And we think that's crazy. We are really optimistic about the fact that on Etherscan, for example, things that are happening on the blockchain have a full lineage behind them where you can go and see, who has done what in an immutable ledger. Unfortunately, there we go. So if we go and look at the, Flashbots builder over here, some random thing that I'm just clicking on, we should be able to go and see every transaction over time and be able to crawl those transactions to verify that they match user intention. We want this to be available for all data sets. And that's what we were referring to when we deal with lineage.
And if you're talking about the future of data, actually, with Weavechain, we try to take it one step further and also monitor the reads.
Mm-hmm. So you're saying that in a lot of these are asset transactions where things are actually being moved between parties. But here we're saying even if no data is let's say, being changed, we would still have a record of its access.
Yes, on Etherscan you see the changes to the ledger, but not the readers. And this is obviously not possible to be tracked in Ethereum, where you have all the distributed networks. But if the network itself or the nodes that are part of the network are doing auditing of the reads, and obviously the reads are carefully shared. I mean, there should be some role-based access there, so not anybody can see what data you are using, but still there should be a trace of the data that you are using, especially if it's monetized data.
Well, I mean, you just led us to our next bit over here, which is around privacy. And really, this is one of the challenges that we see with public blockchains, is that everything is in plain sight for everybody. And this is a problem if you're dealing with sensitive data sets like personal information or healthcare data. And, these things just cannot exist in these public environments because of regulation like GDPR and HIPAA. And in the case of who's going to be accessing my personal data, I don't want that lineage to be on a public blockchain. I would like it to have these cryptographic guarantees of immutability, but I would like some privacy here. And this is really what's one of the special features about Weavechain. We have designed our layer 0 pattern to emphasize that need for privacy and say that we should have these firewalled subnets that need to be properly permissioned for access, instead of saying that we're going to go and put it on something like public IPFS, where anybody in the world can go and access that data.
Before we continue, I would go back a bit to the lineage part. So again, in the context of the future of data, right now there is another AI cycle, and it's a lot about the language models. I assume that there will be yet another AI cycle about the lineage of the data used when training AI models. And this is actually, there are two levels there. One is the lineage of the model itself. So to have a provable cryptographic proofs of your model being the result of certain input data and a certain training algo. Well, there's some randomness involved there, but still you can audit the process and have the proofs for it. And the second thing is to be able to check the data that enters the training. So without seeing the data itself, to be able to verify or have some information about the integrity of the data set that was used, and also to be able to check, let's say, if copyrighted material was included in the training of a machine learning model or a neural net. And the good news is that this is doable today.
Yes, it is. So just to give
the adoption.
As with all great technology, and there's a famous quote that said that, if you could go and get 5 companies to agree on the same technology to use, you wouldn't need blockchain. And it's definitely true, but this is why things like HTTPS have been so impressive, because it was a standard that people agreed upon for these flows. And really, that's what we need out of the world right now, is to adopt specific standards that people can conform to. But to go and give a little bit more color to your AI example, that fancy logo that I put on screen over here was generated with Adobe Firefly. And, I was able to do this with a simple prompt describing, what we're trying to go and portray over here. But artists are pretty scared at the moment, for me as an amateur to be able to create a high quality image like that with nothing more than a prompt is pretty wild. And there was a really interesting article of writers that are trying to go and figure out how to go and ensure that they are going to be given credit if their work was used to train these large language models, or these generative AI for image generation. It's a very, let's say, dystopian moment for society, where there's a lot of FUD around whether or not AI is going to be a boon or a curse for our society. And I think that while many of those fears are overblown, it is very prudent for these creators to be concerned over here. Jenny, I feel like we'd had one more fun article on this subject. I think this is the most interesting one, right? Is going and seeing if people can go and be used. The other one was just I'll switch subject to data economies unless you have anything else to add on this subject. Well, the fun next step, I think then, is that let's go and say that the artist whose work was used to go and generate, or let's say inspire this fun image over here, we're going to get compensated by Adobe for their role in training the language model. Well, this is where we go and get to data economies, where the ability to go and access this data should come with a cost. This is the way most capitalist societies work, is that goods of value are never just sort of exchanged freely. They're always exchanged at cost. And one of the cool things about Adobe Firefly in particular is that they have promised that if your work was used to train their generative AI product, that they will go and find out ways to go and compensate the source, the creators who built that material that was used for training. This is still very early days. Hopefully my TechCrunch article will load up over here in a moment. But people understand that these economies are coming. And it's my belief that digital assets are actually the best way to execute these transactions, because it's so much easier to move crypto tokens around than it is to actually move fiat currency. We are big fans of regulation in the space. Recent events this week may be overreaching in terms of, let's say, what's appropriate to do when there is no actual rules to the game. But in general, we want there to be regulations around how value can be transferred between parties, and we do think that crypto tokens are a great way to do it. I think we're supposed to go and actually fill out our to-do list over here, Johnny. So I definitely want to go and dive into data economies using tokens at some point in the future. We should probably go and do a session that's purely on these security attributes, right? Like how to do cryptographic guarantees of immutability. Guarantees of immutability.
And
we talked about lineage.
Lineage, yeah.
So
lineage, I would split the lineage into data lineage and computational, yeah.
Yep. Where would you put AI on the spectrum? Probably both, or
AI is just something that yet another task that is trained.
And what were your favorite proofs here? It was proof of inclusion or proof of use in training.
Yeah, that's one. That's the one that I would say is specific to AI, maybe.
Yep. Cool. And privacy. We did skip over the confidential computing stuff over here to jump straight to the data economy bit.
Yeah.
But
is a big topic. It's definitely a full session.
Oh yeah.
And maybe in the context of future of data, there's also edge computing that should be mentioned at some point.
I think we can include a lot of that in the confidential computing chat.
Yeah.
So I'll back up for 1 second over here just to note this privacy bit. One of the really interesting things that's changing right now is that historically there was a lot of data that was just replicated between parties when access was required. So let's say that a hospital was trying to go and share medical data for use in a study by a pharmaceutical company. Let me see if I have my old deck on. Here we go, tech interoperability and standards. So what the hospital would do is they would go and internally anonymize all of the user's data, and then literally go and prepare a set of DVDs or data that they would upload to an FTP server to go and make that data available for the researchers. Now, what's better than copying anonymized or redacted data is to enable research without ever moving the data at all. And that's what confidential computing allows you to do. There are a variety of different forms of confidential computing that we enable here at Weavechain. Everything from, let's see if I can get my fun slide over, even though we'll dive into it another day. Here we are.
The slide is not visible.
Just dragging it over. So again, that data obfuscation is sort of the basic way of doing things, where I would hide names, but still provide the data to another party in a raw format. Better is if you go and never have the data leave the local environment and just enable computation, or utilize things like multi-party computing, homomorphic encryption, federated split learning, and Merkle trees and zero knowledge proofs. But in all of these scenarios from 2 onward, the data is never copied. Only the results are made available to users. Maybe I can even show a super fast demo using Weavechain. Let's see here. So we always do the example where, let's say that I am a hospital that is trying to go and make some medical data available for research. We'll go and make that data available from a Weavechain node. And then if I'm a researcher, I will go in my Jupyter notebook, use some Python code to connect to that Weavechain node. Maybe I will be able to read data like a directory of hospitals over here, public information that has nothing sensitive over here. But if I try to go and read patient data the same way, I will get a not authorized prompt. What confidential computing allows you to do is run calculations against that data without being able to see it. So if I wanted to go and say, understand the correlation between smoking and severity of cancer, I can run a multi-party computing algorithm for correlation against those 2 variables and receive the result back without ever having seen the data. We think this is a very, very powerful evolution of data access rights that makes things better because, there's less leakage. I, as a user, don't want my medical data out there in the wild where there's a possibility of environments being breached and that data being compromised. It's sort of like, I think there was a major breach recently with one of the major credit analysts in the US. It was either TransUnion or Experian or somebody else. And, they were just hosting a ton of sensitive user information on their servers that when they got breached was suddenly all available on the dark web. If that data is never hosted, well, there's no real possibility of breaching that environment.
Taking this one step further, you could go with the data sharing in the zero trust security direction, meaning you could create islands of data shared on a per need basis, have role-based access and continuous check of the rights. So although the zero trust security is mainly for networks and computers, you can do the same thing. You can apply the same principles for data.
That's right. Did you have a different term for it? So zero trust security is sort of like the blanket term for, assuming that everything's in a breach state and segregating things. Was it zero trust data? I thought you had some term, some fun
you
term
should
for that.
Trust data. I mean, in zero trust in the past.
Yep. Zero trust data management. Yeah, for me, the TLDR of all zero trust stuff is assume the worst case scenario. Assume that somebody is going to get access to your network and breach into one environment. How do you go and identify when there is abnormal activity happening? And how do you make sure that if one environment's breached, that they don't have access to the entire kingdom? Cool. Well, we've gone through the first 4 key features we think of Web3 data. But the last one I'll say over here is that we are big fans of interoperability. So yeah, I think the Go Fair organization has done some of the most interesting work here. And the idea is that if you are a provider of data, you should go and make that data. Let's see if we can find their key principles over here. F was findable. So there should be a way for machines to be able to read that data and even find that it exists using metadata. Accessible, meaning there should be very clear rules for who can access the data and why. For example, for like my medical healthcare information, I don't want anybody to be able to touch that data besides who I have explicitly given consent to, including my service providers. And interoperable means that it's using modern standards. So if we're talking about healthcare data, the predominant standard right now is FHIR data, an evolution of HL7. And this is saying that we're going to use the same terms and data structures for hosting medical data, so that it doesn't matter if one of my hospital providers was using Epic, another was using Cerner. They should all be able to interoperate for research purposes. Let's see if we can get a little pie chart over here. There we go. These are the different electronic health record systems that are storing medical data across hospitals. I see in the US over here in 2019. And, it would be a real pain in the butt if you were, living in Philadelphia with a hospital system that was using Epic, and then you moved to California and San Francisco, and suddenly your hospital was using Cerner, and your medical record couldn't transfer from one of these services to another. By ensuring that these parties are all using, let's say, a FHIR standard, there should be a process for moving the data between these systems very smoothly. And this is what we're promoting at Weavechain. We hope that Web3 is being built in a way that data can be accessed and moved between these different services in a way that is really smooth and seamless. But that's our mission at Weavechain, is to go and bring these features to as many different data sets as possible. We saw a real problem with how Web3 was being built historically because public Web3 solutions didn't satisfy GDPR HIPAA compliance. There's sort of like two key pieces to what's required to be able to do that. I don't know if I have it in this architecture deck over here. But let's just say that to be GDPR compliant, you need the ability to go and delete data. It's something that we think that is a critical feature for all data sets, the right to be forgotten for individuals. And you can't do that with public Web3 data sets like what's hosted on public IPFS or Arweave, or what's in a smart contract. And the other key feature that we thought Web3 was missing was the ability to go and let's say establish firewalls for data, what's referred to as a physical safeguard in HIPAA terms. So for data to be HIPAA compliant, you can't just say it is encrypted with public key encryption, and even though somebody could access it, they couldn't decrypt it because they don't have the key. HIPAA says, no, you shouldn't even let people access the encrypted data. You need to have a physical safeguard in between, the data and who can access it. And why this is important is, let's say that you think that quantum computing is going to materialize over the next 20 years. Well, if all the data is out there on public Web3 and it can't be forgotten, then once quantum computing, invalidates current encryption, then suddenly somebody would be able to go and read all of those health records in effectively a naked format. So this was, sorry, go ahead, Johnny.
Yeah, just wanted to say, so ideally, everything gravitates or goes towards the self-sovereign data scenario. But there are legitimate use cases also for using the cloud or using a data broker. And probably another topic that should be discussed related to the future of data is we believe that in the future, the cloud providers will store encrypted data that cannot be decrypted except by the end users. Mm-hmm. Probably proxy encryption patterns, probably other technologies that will appear in the future, but the long term is that the data in the cloud will be encrypted. In such a way that the cloud is not, let's say the processes on the cloud are not able to decrypt it.
Yeah, so an example of this, it would be currently the way that Facebook stores my data is such that Facebook can go and read all that data. But if we were going to encrypt it at the user level, the idea would be that before I send my data to Facebook, I actually encrypt it with my private key, so that the only people that can decrypt it have to be authorized by me. And I know it's not as simple as just private public key, but this is Is this, could you explain that term, proxy re-encryption
Proxy encryption.
is, yep, a way of achieving this. This is definitely one of the more technical subjects here, but it's a very cool one. Cool. I guess I'll just wrap up here with how the Weavechain pattern works, and then we can wrap up for today and choose a topic for next time. So if we were going to go and jump back to the beginning, what we do at Weavechain is hopefully make Web3 data easy. So our pattern uses an on-prem model where we go and say, let's go and take the existing code and databases that you have running your app today, add a Weavechain node on-prem, and use that node local to your environment to go and give you access to data economies, where you can go and have an X to earn model, trade tokens for data, or have verifiable data, where you can go and have, proof of solvency, proof of immutability, proof of identity, whatever you want. Now, this node right here, that is truly self-sovereign at an enterprise grade, is the root of our network. But we then go and expand that to go and have, a multi-chain model that we think goes and makes that data much more interoperable and easy to use. So let's say that I was going to go and share my data, my healthcare data, with a network of researchers. We call that data sharing arrangement a private DApp model, where only these parties have access to the data, and it's stored locally in each of their environments as appropriate. What we do with the blockchain is go and put anchors of that data to go and ensure immutability. And those anchors could be one-way hashes or zero-knowledge proofs. And that goes and gives the data those nice Web3 security properties without breaching GDPR or HIPAA compliance. And we envision a world where there are a variety of these chains existing in real time, and our Weavechain hub can go and, let's say, route to these data sets using their decentralized IDs on our service. So I think we had that blockchain anchoring over here as a topic. Let's go and say, we'll put that over here like that. Johnny, I think we're ready to wrap up. So what do you think we should talk about on our next call?
Well, we should let the social media decide.
Oh, I like that approach. Well, we'll go and get some polls out there to see what people are most interested in. But let's say, if you were going to go and teach a course on this stuff, where would you start?
What does the Web3 data mean?
Yep.
Start from the basics.
Do you think this would be sort of an overview of current storage solutions? Do you think it's more into the properties of it?
Also about the data the properties of Web3 data.
Mm-hmm. Do you think that's just a deeper dive into these properties that we've just been discussing?
To some extent, yes.
So what do you think I would probably start with these guarantees of immutability and the blockchain anchoring and talking about blockchain technology. I think this is gonna be my vote for next chat. And let's hope that we can go and do this next week. Let's say we'll do some more storage solutions. Maybe we'll start there. Talk about IPFS. Are we storing in smart contracts directly? Trying to think, we could go through a little bit around lineage here. Smart contracts. We could go and show how smart contracts either append data to their state or have lineage by replaying the blockchain. Replaying the blockchain. Any other topics you would want to add to our list for next week?
No, one is enough.
I think so too. Well, always a pleasure chatting, and thanks to everybody listening today. Please shout out on social media if there are topics that you want us to cover. And we're excited to go and build the future of data with you all. Thanks again, everybody.
Bye.